Hey everyone, my name is Dylan, and I'm here to show off the latest feature in MTC 1.4, which is the capability to directly migrate internal images and persistent volumes from the source cluster onto the destination cluster. In MTC 1.3 and below, we were using a process called rustic to orchestrate the migration of persistent volumes, which forced us to have to copy the data essentially twice, meaning that if I had a 20 gigabyte persistent volume on a source cluster, we had to copy that 20 gigabytes of data one time into the replication repository and a second time out of the replication repository onto the destination cluster, meaning 40 gigabytes of data over the wire. This is an obvious inefficiency that we chose to solve for persistent volumes by using a conglomeration of rsync and stunnel to rsync the data directly out of the PVC on the source cluster into a new PVC on the destination cluster. For internal images, we took the same approach. In MTC 1.3, we had to copy the internal images one time to the replication repository and a second time onto the registry on the destination cluster. We have taken advantage of the fact that if you have exposed the route to the internal registry for external network access, then we go ahead and essentially perform the equivalent of a Docker pull, Docker push to get the images off the source cluster on the destination cluster with no intermediary. So before I get into the changes in the MTC UI here, let's go ahead and take a look at the application we're going to migrate. This is a Django web app with a Postgres backend that we've deployed from the OpenShift 3.11 service catalog. So as you probably know, a source to image application from the service catalog gives us one new image stream, which is the output of a build artifact from the source image build process. And we've got a persistent volume that is storing the page count of the app, and you can see in the bottom right here. So with this application, we can take advantage of both the direct image migration workflow and the direct volume migration workflow to really see how MTC 1.4 has improved. So coming back to the MTC web app, we can see that for the most part, not much is going to change from the user experience perspective. So to kind of show that off, let's go ahead and add our OpenShift 3 cluster. And you can see that this page looks pretty much the same that you might have seen in MTC 1.3 and below, except for a new field on the bottom, which is asking for the exposed route to the image registry. So you can see it's an optional field, and it's only used if you want to take advantage of direct image migration, which you can see in the little chat bubble here. It talks about how much faster it is than the two-step process in MTC 1.3 and below. So we obviously want to take advantage of this, and in OpenShift 3.11 it is the Docker registry service in the default namespace. So we're going to go ahead and include that and add our cluster. Once the cluster has been validated and we already have a replication repository configured, we can go ahead and move on to the migration plan wizard. And in the migration plan wizard, you're going to see that from a user perspective, it's going to look almost identical to how you've done this before in MTC 1.3, except there's a new step 5, which asks for essentially the ability to opt out of this new workflow if you so choose. So we're going to go ahead and migrate from OpenShift 3.11 to OpenShift 4.6. We're going to migrate the direct test namespace. And now in the persistent volume selection screen, we are going to go ahead and choose file system copy as our option here. So as you saw before, you can select copy or move. We wanted to choose copy. And we're going to go ahead and choose a file system copy as opposed to a volume snapshot. And the reason for this is that if we really want to use this new rsync workflow, then we don't want to call out to any cloud providers for snapshots, and we don't want to use CSI, anything like that. We want to essentially take a copy of the file system that's in the PVC itself. So in MTC 1.3, this is what was leveraging rustic to perform this migration in the file system copy. But in MTC 1.4, assuming that we've opted into the direct volume migration, this is going to use a rsync and stunnel process to do so. So here in step 5 on the migration plan wizard, you can see that If we so choose, we could decide not to use the direct image and direct PV migration workflow. And the direct image migration workflow would be automatically grayed out if we had selected MIG clusters without an exposed route to the registry, but we don't have that in this case. And if you actually see here, it'll explain that if you want direct volume migration to work, you do need network connectivity between the two clusters, and they have to be able to communicate over port 443. So since we're here to show off this new workflow, we're going to obviously keep them selected, and we're going to have no hooks for our migration plan. So we can go ahead and get this created, and you can see it's already validated, so we are in good shape to start the migration process. Let's go ahead and perform our migration. We want to quiesce the app on the source side, right? So we go ahead and take one more look at this. We're at about 68 page views, and we should expect to see that when the app comes up again on the destination cluster. So if we come back to the MTC UI here, we want to go ahead and see the latest MTC 1.4 improvements here around progress reporting. So if we go ahead and click on our migration, we can actually see a high-level status field here. But if we want even deeper details, like for example, what are all the steps that are going to be running in this case, we can actually click on the MIG migration object itself. And under the migration details, you can notice that there are 2 new steps in the itinerary, one for direct images and one for direct volumes. In the past, you actually saw pretty often that we were taking what can be referred to as a 2-step backup and restore process. So we had one backup that was capturing all the Kubernetes level objects that was not stateful. And then we also were creating a stage backup that was responsible for capturing all of the PV data and all of the internal images. Well, in the new workflow, the stage backup and stage restore is really only needed if you have selected PVs that require snapshots or any type of move PVs. In this case, we only have one PV. We've selected file system copy. We don't really need to run the stage backup and restore process. So the only stage steps that will actually run as part of the stage backup will be creating the direct volume object. And in the background, we actually go ahead and create the direct image resource so that we can go ahead and start copying these images directly from the source to the destination while these backups and restores run. Since we actually don't need the images to be there until the final restore, we can take benefit of some parallelization here to make that process a little bit faster and easier from the user's perspective. So you can see here that we're quiescing the application. So if you take a look here, you can see it's gone down. The stage backup process went ahead and created the direct volume resource, and the direct image resource was already created as well. So we're going to go ahead and wait for these to complete. The direct image process is already completed. There's only one image stream, so really shouldn't have taken that long. And then the direct volume process is going to go ahead and set up a few things before it can actually perform the rsync. So we've got the rsync daemon pod that needs to be stood up on the destination cluster, and then we need to go ahead and configure stunnel on both the source and the destination. And then we need to create a set of rsync client pods, which are actually rsyncing the data directly from the source PVC on the destination PVC. If we want some more details, we can actually click here. You get a running, progress reporting here as well as the transfer rate. So we copied at about just over 5 megabytes a second, and we're already done. So if we go back to the migration details, we can see that the final restore is running. This is what's responsible for actually bringing over all of the Kubernetes level objects, such as the deployment configs and the services and routes. And obviously, the initial backup and the final restore process has gotten a lot faster, and the obvious reason for that is that there's a lot less data to be copied as part of the Valero workflow. So you can see that we're already done. If we go ahead and take a look back at the migration, it's completed. Take a look at our original app, it's still quiesced, and last we saw was at like 68 page views, I think, so we should expect to see somewhere around there when we restore the app. So if we come back to our OpenShift 4.6 console and we find our new project, Direct Test, and take a look at the workloads, we can see that we already have Django and Postgres up and running. So if we want to go ahead and check the route here, here is our new application. You can see that we have 69 page views. So our direct volume migration succeeded. If you want to take a little bit more of a look at what exactly the direct image process copied over, right? So any image streams that were in this namespace, we should expect to see in the new cluster. So if we come and look at our image streams, you can see that our source to image build output, which is essentially the build artifact in this case, this was copied over. You can see one image associated with it, created about 3 to 4 minutes ago, and this was part of the direct image migration workflow. So as you can see, in MTC 1.4, we have gotten a lot faster in our capability of directly migrating a lot of the time-intensive data, which is persistent volumes and internal images. We're seeing a massive performance enhancement there, and hopefully less prone to errors since we have more control over the process itself. Thanks a lot for watching, and please subscribe to the channel if you're interested in more MTC demo videos. Until then, I'll see you next time.